Hello, and welcome to this Eureka webinar in association with Southco. My name's Paul Fanning, and I'm editor of Eureka. Today's presentation is called Quick Access Fasteners Explained and will be given by Nick Bennett, Southco's Global Product Manager. Before I hand over to Nick, however, I should just say to you that if you have any questions during the presentation, please type them into the box on the right-hand side of your screen. And if we can't answer them at the end, we will hand them over to Southco to answer them for you offline. And with that, it just remains for me to hand over to Nick. Nick.
Thank you, Paul. Welcome, everybody. Today, I'd like to talk you through quick access fasteners, as Paul mentioned. And just before that, I'd like to give you a very quick overview of what Southco is about. So we are a manufacturer of access control products. Globally, we cover all the world. We cover the whole continent. We have 15 different global locations with 12 different design sites and manufacturing centers. And we aim to manufacture where we produce, where the customer needs our products. And what we try and differentiate ourselves from our competitors is we are the touch points on our customers' end products. We are the differentiator in making your products stand out from your competitors. And with many, many years of experience in this industry and developing products, we aim to be delivering the service locally that you're looking for. And to support that, we have some 100,000 different standard products in our handbook, which are readily available. But also we have some 40,000 custom products where we take those standard products and we customize them to suit a customer application. So if you don't see what you're looking for in a handbook, please contact us. We can probably find a solution for you. Some other stats there that you can see. We have 150,000 customers around the world, and we have around 100 direct salespeople and technical support staff that can help you with those application design-ins, your technical questions. So please feel free to contact Southco. Contact details are provided at the end. So the purpose of today, why use a quick access fastener? Kind of does what it says on the tin. They are quick to fasten, they're quick to release. So where you have an application that needs fast entry, fast service, this type of fastener is ideal for that. Usually it's either a simple quarter turn or a push-pull action to gain access. Importantly, the fastener provides repeatability. Clamp loads often are important, and over the life of the product, these fasteners will help you maintain that clamp load. So you eliminate over tightening that you would associate with a normal screw thread. And there is no screw thread, so you don't end up with a thread stripping situation, which can render your product inoperable. Perhaps most importantly, vibration resistant. These fasteners are all vibration resistant. They do not come undone under shock and vibration. Typical screws need lock washers or adhesive patches to try and prevent that. These do not need anything like that. And also the components can be captivated. So where you have an application that you can't afford to have components falling into the machinery, into the electronics, the electrics, these are ideal because all of the components associated with the fastening method are captivated in the panel. And what we can provide is different access options. So whether you want a simple hand operation for ease of use, or perhaps you need tool-operated access for higher levels of security to stop the casual user from opening something. All of those can be provided across the range. And because of all of those features, we do cover many different industries: aerospace, industrial machinery, lighting, automotive, off-highway in particular from a vibration-resistant perspective, and network and telecommunications, where captive fasteners are important. So lots of different industries, lots of different markets, lots of different applications. So the whole range is quite a broad range. It has lots of different operating modes that should suffice and cover most of your application requirements. We have lots of different finishes and materials. So whether your requirement is for an aesthetic finish or environmental protection, we can find a solution for both of those. And we also have a broad selection of sizes across most of our ranges. So whether you're looking at a light duty application or indeed a very heavy duty application in perhaps off highway, we would have a fastener to suit. And we also have lots of different installation methods. So just thinking about the manufacture of your product, we can cover different manufacturing processes within our standard product range. So because that range is so vast, what I'd like to do today is just cover what we call our Zeus quarter turn range and give you some background on that. So focusing on that, and actually a very brief history, the Zeus quarter turn fastener, and some of you may be familiar with the Zeus brand name, it was invented pretty much 90 years ago by a guy called William Zeus, based in Long Island in New York. He set up a factory manufacturing fasteners for the aircraft industry. And those fasteners quickly gained some credibility and very quickly were patented as the first quick-acting, self-locking fastener. William Zeus, due to the success, expanded into Europe, into the UK, and some 70 years later, that Zeus brand, that Zeus product, was incorporated into the Southco family, and now we make those fasteners globally to suit our customers all around the world. And you can see on this image, these are the fasteners in situ, and actually we still make those original fasteners today for the aircraft industry. So let's look at the technology behind it. What actually comprises a quarter turn fastener? So to put a kind of a technical spin on it, all of the fastener systems have one component with a cylindrical cam profile form, which engages with a complementary form on a mating component. I appreciate that sounds quite convoluted. It covers lots of different ways of achieving the same functionality. So we'll come on to some examples. But what it does do, the cam form enables the fastener system to draw two components together and to create a compressive load. And at the end of the cam form, that rotational cam profile, there is a small return feature. And this is essential in providing the vibration resistance and holding the fastener closed under shock and vibration. So I've taken a couple of screen grabs from a video that's available on our website, just showing how a typical fastener comes through the top left image. The fastener, you can just see the nose of the stud, comes through the fastener. The second image shows it engaging with the wire form on the back of the receptacle. And then the third image and the fourth image show further rotation of the stud to fully engage and to lock in an over-center condition. So that fastener will not now come undone until you undo the fastener. No vibration or shock loads will force that open on its own. And I mentioned the video can be seen on our website should you want to watch that in full. It's available for everybody. So let's look at the fastener itself. So I mentioned studs. So the stud component is what essentially fastens to the moving panel, or in most cases the door. And there is a receptacle, which is the mating component, and this will be attached to the frame or to the fixed panel and provides the engagement. And thirdly, there's a retainer. The retainer is what holds the stud into the moving panel or the door. and that's what prevents it from falling out when it's unfastened. So typically it would look something like this. You can see the stud is pushed through the door panel, secured with a retainer, and then the receptacle is attached to the frame and that stays fixed. So within our range, there are actually 4 main types of fastener. There's what we call the internal spiral cam, and you can see that the cam form that I mentioned earlier is machined into the component. So this is CNC machined. It's the original design of fastener. This is the one that's some 90 years old, but is still very popular today. More recently, the external spiral cam was developed. Works in a very similar way, but rather than being CNC machined, it's now cold formed. And so although you get all of the benefits of having the cam profile, the manufacturing process is much faster, and you do end up with a more price competitive product with the external spiral cam. An alternate way of achieving a very similar functionality is what we call our spade cam. And you can see that the images there only show a spade form on the end of the stud. And that's because the cam profile that's so very important to this product range is actually included in the receptacle instead. So the spade cam fasteners are, if you like, an inversion of the external spiral cam or the internal spiral cam, but they still work in the same way. They still have the quarter turn operation. They still have the over center locking. They still provide the pull up and the compression that the fastener range provides. And the 4th type we have is a push to close, quarter turn to open product range. And as described in the description, you simply push these fasteners closed and you then quarter turn to open them. So it's a slightly different way of using the fastener. Function is the same. There is still some over center locking, so they don't come undone under vibration. So I'm sure what you're thinking is, that's great. How do I choose one form over another? And we have a quick table that shows the effect of the cam form on a number of different performance criteria. So for example, the cycle life on the external cam and the internal cam is what we call medium. A medium is typically 500 up to 2,000 cycles. If you compare that to a standard threaded fastener, maybe a screw, that's usually significantly more than you would expect from the life cycle of a screw. And actually our spade cam and the push to close, quarter turn to open fasteners will achieve an even higher cycle life. And what's important to note is that the function of the fastener over those cycles will not deteriorate. So you still have the same clamp loads, you still have the same operational torque, which cannot be guaranteed if you're using a threaded fastener. The tensile loads again vary across the product range, as does the vibration resistance. And now it's important to note here, vibration resistance is not whether the fastener comes undone or not. These fasteners do not come undone under vibration. The vibration resistance refers to the fact that because our cam profile has the over center function that prevents it coming undone, it does mean that there is some compliance in the fastened system. And that's to say it does allow a small amount of movement in and out from the panel fastening direction where vibration can occur. It won't come undone, it remains secure, but there is some free movement possible under vibration. And this particular section of the table is indicating how well the fastener will limit the vibration of the panel under that vibration load. Corrosion and chemical resistance, lots of options, including stainless steel for those highly critical applications. And TMT tolerance, I will come on to that a little bit later. That's an important factor in determining the stud and receptacle combination. And as I say, I will come on to that shortly. Access control, I did mention at the start. So we do have two different types of hand operation. And you can have a bail or a wing or a knob style for finger operation. Or we have tool operation. And many of our fasteners come with different tool recess options, depending on whether you want common access with, say, a slotted or a Phillips or posi drive screwdriver, or a more specialist tool, including Torx, and the Torx High Security are available in some of the options. So let's just think about design considerations. I think most people are familiar with designing an application that is fastened with a threaded fastener, a screw, and a nut. The Zeus quarter-turn access fasteners are slightly different. They do have the overlocking feature, which is fundamental to the vibration resistance of the fastener. I mentioned the compliance in the direction of fastening. So under vibration loads, there can be some movement of the panel that is being fastened, but the fastener itself is secure. It will not come undone. And most importantly, this is predetermined at the design stage. Often with a threaded fastener can be designed in, but the specification, the length of the screw, for example, may not be defined until you get to the end when you've looked at all of the screws you have in your application. This really needs to be thought about in the design stage. The length of the stud, because of the overlocking feature, is critical in any application. If the stud is too short, the system cannot be fastened. If the stud is too long, then it will come undone under vibration and you will lose all of the benefits associated with the system. So the Goldilocks effect, if the stud is just right, then what you will end up with is a secure, vibration resistant fastening and the desired clamp load. And TMT, so I mentioned that a couple of slides ago. The TMT is the total material thickness of the door, any gasket, the frame thickness, and any retainers. So it's a combination of anything that comes in between the head of the stud and the fastening surface of the receptacle. So if you like, you take the tolerance stack up or the material thickness stack up and you use that in the calculation to calculate the appropriate length of the stud. And I appreciate that all sounds very complicated compared to a standard threaded fastener. But actually the benefits of doing this certainly outweigh the issues that are seen often with the threaded fastener. So how do we go about selecting a particular fastener range? You need to consider the performance characteristics, which we showed a few slides ago. You need to choose the most appropriate receptacle for the application. And that could include the installation method, the materials, the finishes, and even ingress protection. If you want to keep moisture out, then you need to consider that at the design stage. And finally, we have to calculate the TMT, the total material thickness, including any components that come in between the head of the stud and the receptacle. So what I'd like to do is just take you through a working example of that, just to see how it would work. So I'm going to choose one particular fastener on a range. I'm going to choose D8 because the size is appropriate for my application and it offers the head styles that I'm looking for. So first, having chosen that particular range, I have to choose a receptacle. And in this instance, this example, I'm going to use a weld-on receptacle, which is welded to the back of the frame. So it's a very secure, suits the application. and comes in from the back of the frame because I have access to the back of the frame. Where you don't have rear access, you probably need to choose a different receptacle. So I've chosen the D8-334-500-121 receptacle. And now I need to calculate the TMT, the total material thickness. And I know I have no gasket in this particular case, and I'm going to use retainer, the D8-324-100-040. So from looking at the handbook page and the user guide, this will direct me to saying, okay, I need to use the right-hand image in the handbook and the TMT calculation as shown, with a frame thickness of 1.5 millimeters and a door thickness of 2 millimeters. And all of that sounds very complicated. It's a very simple sum where I add together as directed the panel thickness, the frame thickness, and an allowance for the retainer thickness. And in this particular example, this would give me an overall TMT of 4 millimeters. At this point, it's worth noting in the handbook page, there's also a helpful stud selection column, which the first time you do that doesn't mean very much. But as you move on to the next stage, you will see that this helps you in selecting the stud. So make a note of which stud selection column is indicated in the table. So onto the stud style. I'm going to choose a tool actuated hex recess because I want to have limited access from a user perspective. They have to have an Allen key, not just a screwdriver. And referring to the stud length table and in particular the column A that we've just got from the receptacle page, you can see here that there are a range of min and maximum TMT dimensions. And the first step is to scroll down the table and to find the TMT dimension that relates to the one that I've just calculated, which was 4 millimeters in this example. And if I look across the table, I can see that there is a K reference, and in this case number 11, and that refers to the length of the stud. For this particular range, it also refers to the physical length in millimeters. That's not always the case. So just be aware that sometimes you have to use the K reference number, not the actual length in millimeters. And finally, I would choose a finish option for the stud. I'm going to use a standard zinc plate. So this would give me the finish option of 170. So taking all of that information together, I can compile a part number from the part number creator. So I can see that it's a D8-314-2 for my hex recess, 11 because that's the K size that I found from the table for the stud. And I've realized in here I've put the wrong finished part number just to catch people out. I wanted the 170 and I should have put 170 in the part number. So I whizzed through that fairly quickly. There is lots of information that can be found on our website. We can access it through the Zeus quarter turn page, which comes under the fasteners section and the products on our website. And in there, you will find lots of details about our quick access guide, some of the case studies that we've performed, and lots of examples of applications where the products have been used and the benefits that can be seen. And finally, I would just like to say, if you do have any questions about the content you've seen today and the quick access range, or indeed any of our fasteners in general, then please feel free to drop me an email. We also have a general inquiry email from our customer service team. That's info@southco.com. Or you can go onto our website and use the chat function where we have 24-hour support from our customer service departments around the world. So please feel free to contact them and to ask any questions you might have.
Thank you very much, Nick. Just a couple of questions we have here.
Okay.
First of all, what are the relative advantages of bale head and wing head fasteners?
Okay, that's a great question. So I'm just going to stop sharing this and switch back to camera. So if I take an example of a wing head, so you can see it's actually from the side, it has a finger grip, which you can operate by hand, but it does protrude from the panel all of the time. So if you have an application where people are pushing past or walking past, you might not want something that sticks out quite as much. The bale profile is a similar function. You can operate it by hand, so it works the same way. But with this one, you can now fold it flat. So it's more cleaner. It has a lower profile against the panel. So it prevents that catching of things as you walk past it.
Okay, thank you very much. And next, what industry standards are the products applicable to?
Wow. Okay. So as I mentioned at the start, we do have lots of different customers in lots of different industries. We have lots of certification for aerospace. We are compliant with many of the automotive standards. Shock and vibration testing is often specific to a particular application or particular customer. So I would say if you have that, come and talk to us. But we can show compliance to many of the standards. Let us know which one you need to adhere to, and we will make sure you have the information that shows compliance.
Okay, thank you very much. Unfortunately, that's all the time, all the questions we have time for today. But if you have asked any questions and we haven't been able to get round to them, do rest assured that we will be handing them on to Southco and they will answer them for you offline. And with that, it just remains for me to thank Nick very much for a great presentation and to thank you all for joining us. Thank you very much.
Thank you.